In 1992, the Residential Lead-Based Paint Hazard Reduction Act, known as Title X, shifted the United States public health strategy. The objective moved from treating lead-poisoned children after the fact to primary prevention, identifying and managing the hazard before exposure occurs. The primary operational environment for this legislation is target housing. This classification assumes any residential dwelling built before 1978 is a potential hazard zone requiring investigation. Mapping this environment requires a certified professional, the lead-based paint inspector. Under the outdated reactive model, interventions only occurred after blood tests confirmed a child was already suffering from lead toxicity. The modern proactive protocol requires physical structures to be investigated before they are occupied. In this framework, the inspector serves as the foundational intelligence gatherer. Without the precise surface data they collect, targeted hazard control and abatement operations cannot be executed. A common operational error is conflating the role of the lead inspector with that of a risk assessor. The risk assessor is tasked with a diagnostic mission. They evaluate current exposure risks, identify deteriorating paint conditions, sample household dust, and prescribe specific remediation controls to neutralize active hazards. The inspector's authority is strictly limited. They do not evaluate health hazards. They do not assess the condition of the paint. They do not recommend abatement strategies. The inspector's mandate is pure binary intelligence gathering, a surface-by-surface investigation to answer one question: is lead present or is it not? The resulting data creates a definitive inventory of the entire structure. Every painted component must be accounted for and tested, even if the paint is currently intact and in perfect condition. Federal law deliberately separates the identification of lead from the assessment of its risk. This separation ensures that property owners base their compliance and disclosure decisions on an objective, unbiased chemical baseline. The federal target threshold for lead-based paint is absolute, a concentration equal to or in excess of 1.0 milligrams per square centimeter, or 0.5% by weight. To accurately map a structure against this threshold, random room sampling is prohibited. Inspectors must categorize the environment using a strict protocol known as the testing combination. This 3D matrix breaks down three variables. First is the building component itself, a door casing or window sash. Second is the underlying substrate, wood, plaster, metal, or drywall. Third is the painting history, determining if identical components share the same legacy. For example, if a room contains an original 1920s window alongside a replacement window installed in 1985, their painting histories diverge. They constitute separate testing combinations and must be analyzed individually. The inspector has the authority to exempt specific components from testing, provided there is definitive, documented proof that the component was replaced after 1977. This requires a meticulous visual sweep of every distinct area, legally defined as a room equivalent, to ensure no variable is missed. By executing the testing combination protocol, the inspector ensures no toxic surface is hidden by assumed uniformity. The result is a legally defensible data matrix. The primary tool for this field intelligence is the X-ray fluorescence, or XRF, analyzer. It allows for rapid, non-destructive chemical testing. The device utilizes a radioactive source to penetrate the paint film, exciting electrons of lead atoms to emit a measurable X-ray signature. Readings falling within the specific inconclusive range cannot be legally classified, and dense substrates require baseline formulas to prevent artificially high readings. To verify accuracy, the inspector must perform mandatory quality control checks using standard reference materials calibrated by the National Institute of Standards and Technology. Calibration checks are required at the shift's beginning, at the shift's end, and periodically throughout complex operations. The hardware is highly advanced, but the data relies on the inspector's rigorous adherence to these mathematical and operational tolerances. When an XRF reading falls into the inconclusive range, or when non-destructive technology is unavailable, the inspector must execute a contingency protocol. This requires shifting to destructive testing, paint chip sampling. This method requires physical extraction. The inspector uses specialized tools to remove all layers of paint film, cutting entirely down to the bare underlying substrate. The objective is to sample the oldest, deepest layers of the coating system. Historically, the base layers applied directly to the substrate contain the highest concentrations of lead-based pigments. To secure enough mass for laboratory analysis, the inspector typically extracts at least 2 square inches of intact paint film per sample. Samples are logged under strict chain of custody and transported to an EPA-recognized laboratory, accredited by the National Lead Laboratory Accreditation Program for quantitative analysis. While invasive, physical extraction removes all ambiguity. It guarantees definitive chemical intelligence, eliminating the inconclusive variable from the mission parameters. While Title X sets the federal baseline, inspectors must adapt to their specific geographic jurisdictions. Along the Texas Gulf Coast, regional mandates amplify federal law. Operations here are governed by the Texas Environmental Lead Reduction Rules, or TELRR. Texas imposes stricter administrative controls, requiring personnel to execute biennial certification renewals rather than the standard 3-year EPA cycle. Furthermore, TELRR strictly mandates that all lead identification activities be reported directly to the state health department by the 15th of every following month. Operating in an authorized state like Texas with only a federal EPA certification is a severe compliance violation. Federal regulations write the tactical doctrine, but the local environmental and administrative parameters dictate the true operational reality on the ground. Beyond the initial mapping of a structure, the inspector serves a critical secondary function after hazard elimination work is complete. This is the clearance examination, an independent, quantitative verification that an abatement crew successfully neutralized the lead hazard. Clearance begins with a rigorous visual assessment. The inspector evaluates the work zone to ensure zero residual dust, paint chips, or construction debris remain on site. If the visual inspection is passed, Phase 2 triggers quantitative dust wipe sampling. This chart maps the collected microgram loads taken from high-risk surfaces, like floors and windowsills, directly against strict federal limits. For interior floors, the EPA and HUD action level is highly restrictive. The load must test at less than 10 micrograms of lead per square foot of surface area. To prevent data manipulation, federal law mandates a strict conflict of interest protocol. The clearance examiner must be entirely independent of the firm that performed the abatement. If a single dust wipe fails to meet the action level, clearance is denied. The abatement crew is required to re-clean the entire space before a secondary examination is scheduled. The clearance examination acts as the ultimate fail-safe. The inspector is the final gatekeeper, withholding authorization until the data proves the space is safe for human reoccupancy. Every XRF reading, testing combination matrix, and NLA Lab laboratory result converges into a single comprehensive document, the Lead Inspection Report. Under the federal lead disclosure rule, sellers and lessors are legally bound to provide this report to buyers and tenants before finalizing transactions for pre-1978 properties. A deficient or inaccurate report carries severe liability stakes, exposing property owners to federal penalties and civil lawsuits if a resident is later poisoned. From categorizing the initial testing combinations to executing the final post-abatement clearance, the inspector operates on an uncompromising technical standard. The Envirogyn protocol relies on the repeatable execution of these federal standards. By strictly observing the mandatory calibration, sampling, and reporting intervals, our investigators provide the technical baseline for any property management strategy. By isolating the chemistry and relying on strict tactical protocols, precision data turns lead paint from an invisible, assumed threat into a neutralized, fully managed problem.